Hello everybody, welcome back to Mrs. Baker's Monster paper for Module 5. This is question 2. Okay, so ammonia is used to produce nitric acid, which is HNO3. This happens in a 3-stage process. Stage 1 is a redox reaction. In this reaction, the predicted yield of nitrogen monoxide is 512 grams, but the actual yield is 384 grams. So we've got a predicted yield of this and an actual yield of this. It's asking us to calculate the percentage yield. Well, that's easy. We do what we actually have, which is 384, over what we're supposed to have, which is 512. You can think about it like I've got 384 out of a possible 512, and then I just times that by a 100 to get it into a percentage. So let's do that on the calculator. 384 out of a possible 512. We times that by 100, and that gives us 75%. So we know that our percentage yield is 75%. Question 2 continued. This is the equation for the reaction in stage 3. Calculate the volume of oxygen gas at RTP needed to produce 1,260 grams of nitric acid. So again, we're just going to call on our table method here. And if you wanted to, you can just do the table method in any place on the question paper. So I'm going to show you where I would do it if I was writing on the actual question paper. So I know that I'm going to need O2, and I know that I'm going to need 4 HNO3 because that's what I've highlighted in the question. I know that oxygen is a gas. It tells me that here, but it's also, I know because I have no fear of ice cold beer, and I know that oxygen is always a gas at room temperature and pressure because I'm a chemist. And I know that it's given me the 1260 grams of nitric acid. So I know that I'm in my mass mole MR triangle when I'm dealing with the nitric acid. And I know I'm in my vol mole 24 because that's the gas triangle. So I'm going to need to add to my table the mass, mole, and the MR. I'm also going to need to add the vol and the 24 if I so choose. And remember, I'm just looking for 2 bits in a column, and then I can solve a third. So 24. It's given me the mass, which is 1260 grams of this. 1260 grams. I can work out the MR of this using the periodic table. So the MR of this is 1 plus 14 plus 16 times 3. So I'm going to do that on my calculator. I'm going to do 16 times 3 first. Then I'm going to add 15. That gives me 63. Now I can work out my moles because I've got my mass and I've got my MR. My mass divided by my MR. So I need 1260. I divide that by 63 and that gives me 20. So I've got 20 moles of that. Now I know I've got a 1:4 ratio. So I need to divide this by 4. That gives me 5. So I'm going to show the examiner my workings. I'm going to show the examiner my workings by doing 20 divided by 4 equals 5. And then I know I've now got my moles. I just times that by 24 to get my volume of gas. So I've got it on my calculator ready. Times by 24. It's nice and quick. 120. So again, I'm going to do the same. I'm going to show the examiner my workings because in mole calculations in paper 4, even if you make a mistake at the top, you do get an error carried forward. So it's really important to show your workings. So in this case, for the volume, I'm going to do 5 times 24. And I'm going to say that gives me 120. Right, what do I do now? I'm just going to pull this information from the table into the answers. Calculate the number of moles of nitric acid. Well, that's here. That's 20. Deduce the number of moles of oxygen. That's easy. That's 5. Calculate the volume of gas. The volume of gas is 120 decimeters cubed. That's four marks, super quick, much less than 4 minutes because you've used the table method.